All right, hi everyone. My name is Blake Anderson. This talk is about Rhovas, which is the programming language I've been building for API design and enforcement. The way this talk is going to work is it's split up into two parts. So the first part is going to be mainly on the motivation and philosophy behind the language, like why I decided to write a new language in the first place. And then the second half is going to be kind of a series of examples and just kind of language tour of everything that Rhovas has and some of the cool features that I just kind of want to show off. Not meant to be exhaustive, but hopefully it should be a fun mix of things. So let's jump into it. So motivation and philosophy. We're going to kind of cover these whole sections of things. Stick to this too close, but the main two takeaways that I want to give are first the theory of software APIs, which is something I kind of defined for Rhovas. That's the core problem the language is trying to solve. And then second, the three design pillars for Rhovas, which is kind of a set of guidelines that documents how I kind of decide what features go into the language. So those are the main two general takeaways, but there's other kind of good general information here too. So let's jump into it. First things first, what is in a language? Language has a lot of different pieces to it. The largest one is probably just the design and implementation, which is the core language. So your design is kind of all the structure of what features that you have in the language, what things that you offer. It's really kind of defining, who is the audience that you're building a language for, what problem do they have, and how is your language specifically trying to solve for that problem. A great example of this is Rust. The Rust programming language is really well known because it has a very simple tagline that describes what the design is, right? It's for low-level, memory-safe programming. Right? It has that whole ownership and borrowing system, which is kind of the main selling point behind Rust and why people decide to use it over other low-level languages like C++. Of course, you have your implementation, something like a compiler or interpreter, whatever you're using to actually run code. That's very important too, but just not the subject of this talk. Then you have your environment. So these are things that are kind of tangential to the language, but ensure that the language is usable. So the standard library is really the largest one. If you don't have a standard library, it is very difficult to do useful work with that language. Your standard library also really kind of reflects back into the design of that language. For instance, if I'm building a language that is intended for building like web front ends, then I expect the standard library is going to be pretty good at things like DOM manipulation. It should be able to do network requests like a fetch API. And then it may even have some particular language features like the little HTML tags that we see in React. Fun fact, that's actually done using a known language called JSX. So you're not writing JavaScript or TypeScript, preferably, but you're not writing either of those languages. In fact, you're writing a little hybrid called JSX, which is what allows those HTML literals to be used. Then you have tooling. Tooling is a mix of a lot of different things, too much into it. But it's things like an IDE, something that can support like auto-completion, navigation, syntax highlighting, stuff like that. But it's also things like your build system, so you can actually compile and run a project, manage dependencies for that too. Tooling is also useful for things like testing, so you want to be able to test code. Debugger is also nice. And then probably farther down the line, hopefully you'll have some type of standardized package manager or something like that, so people can host and pull down dependencies and just work seamlessly throughout the whole environment. And then lastly, you have the community. Obviously, this is where people are going to be looking to try to figure out how to actually use the language. You're probably going to want some type of support forum or place where people can report issues. So that's a huge thing. And then also just in general growth, where ideally those people will be writing new documentation or blog posts or even new entire libraries for other users of the language to create. And this is part of the reason where this is going to kind of do a feedback cycle back into design. Because it's these users, as they continue to kind of grow and use the language, that are going to set the direction for what the conventions of the language are and how the language tackles particular problems, and even to some extent, exactly what problems those are. So I kind of have these listed, roughly top to bottom. There's no particular order of these. I wouldn't try to imply one is more important than the other. But obviously, language comes first, and so we're going to be focusing mainly on the language design for right now. So quick story time. Back when I was in high school, I started programming, and I kind of mainly learned programming by building Sponge plugins. Sponge is a Minecraft modding API, and so the way that it kind of made its name was it was set up so that it could handle client-side mods when you're using server-side plugins. And so if you're not too familiar with how game modding works, the gist of it is that the client side can mod the game and introduce a whole bunch of new features. In the case of Minecraft, this was things like new blocks, new items, new entities, all kinds of things that really kind of change around how the game works. And your plugins need to be not necessarily aware of these, but they need to be able to work with them well enough. For instance, if something hard codes just a list of all of the blocks in vanilla Minecraft, then once a mod gets added in, that plugin would not be able to support those new features. And so Sponge came in and tried to solve this problem, which is not an easy problem to solve because mods can change literally everything. So it was a very relatively complex API system that it had to handle all these different possible changes of implementation and breaking up the different states of what could happen in the game. And so working with Sponge, I learned API design. Things like Java's optional class, which is like to represent nullable types. Things like mutable and immutable lists, which we use to kind of help guide people in the right direction for API decisions. And then also larger things just like software design patterns overall. All kinds of things, factory, builder. Side note, builder, favorite design pattern. Not sure if everyone has one, but I do. Mine's builder. And so anyways, so I work with a bunch of these Sponge things, and I also built my own libraries using Sponge that other developers were using. And so this is an experience not only to see like how I was able to use an API, but how I could turn around and make that API better to fix problems people were having. And then in turn, I would get feedback from these developers that would tell me, hey, this thing that you did was good, or hey, this thing that you did was not very good because I have no idea how it works. And it's particularly the cases where people come to you with problems that are very important because you not only want to see, you not only want to fix the problem, but you also want to determine how did they end up in a situation where they had that problem in the first place, right? What was unclear or confusing enough for them to run into a particular problem of this form, and where should I have done something different to help guide them in the right direction? Sometimes that's through better API design, other times that's through documentation or whatever. We'll talk about the specifics of that later. A little later on, all of us here live, at least not recording, know of SSD, but SSD is the organization at University of Florida called Society of Software Developers that I founded back when I was an undergraduate at the University of Florida. And so the main point of SSD was to something where people could learn about software design, because that was something that wasn't really too well covered by classes at UF, especially for kind of the earlier undergraduate classes. It wasn't until you got into a lot of the project-based stuff later on that you saw that. And during one of the earlier projects, I had been with a group of people who were pretty much capable of coding, all things considered, but what they lacked was the experience building software like I had with Sponge that kind of described how to build APIs, how to do things like design patterns, and build these types of complex systems. And so that was kind of the niche that I wanted to fill. And so that kind of brings us to this, which is the theory of software APIs. And so from all these experience, I kind of thought about what types of problems, what things that people had that went wrong, and it led to this conclusion, which is that the majority of issues in software development are caused by incorrect assumptions about the API of any given software, including your own. Probably particularly your own, because most of the time that's where you make the most mistakes, but all software in general. And so when talking about APIs here, I'm specifically referring to like the interface, so like functions, classes, whatever else, not necessarily like networking APIs, though obviously that applies too. And so it was this whole structure of things where you make these assumptions about your code. So you assume that indices don't go out of bounds. You assume that input given by the user is hopefully valid. You assume that things won't fail in certain edge cases. Or when you do go and look at the documentation, what you find is that it isn't actually present. And so what happens is you have to trial and error your way through the system until you get a result that actually seems correct, and then just hope that the behavior doesn't change later on. So the end result is the solution that I kind of identified is simply just to prevent or at least minimize incorrect assumptions. Right? If the problem is caused by people making incorrect assumptions, then the solution is very easily don't have people make incorrect assumptions. So one way, the easiest, is probably API design. Better architecture is obviously going to reduce the number of questions people have about your API design. And a huge piece of this is consistency with conventions. For instance, Ruby on Rails, which is the language I work with now, is a very kind of convention-heavy language. So they actually say convention over configuration. So that's kind of a thing out of Ruby. And so if you're building a library or any type of code, you want to stick to the conventions that are present in Ruby /Rails, and that'll make it easier for other developers to understand how to work with that library. Alternatively, if I was writing a library for, say, Python or JavaScript or Java, then I would look at finding what the conventions are for those languages and probably stick closer towards those. That way it would be more familiar for people with an understanding of those environments already. Next piece here is enforcement. So for example, compile time, runtime stuff. Obviously, the more that we can enforce at compile time, the better. This is things like static typing. But there are a number of things that we just can't enforce at compile time. There are theoretical limits to this, but the more practical thing is that, even if there weren't theoretical limits, some things are just really hard, and it's easier to validate it at runtime, particularly because it involves, data from users. That's a great example, but other things as well. And so what we want to do is we want to try to do as much enforcement as we can as quickly as possible to effectively maximize the developer feedback loop. The faster the developer knows that they've run into an issue or have opened themselves up to the possibility of one, then the sooner they can fix that problem, and the less likely it is to cause an issue down the road. The last one here is documentation. And so this is for things that are contracts that can't be forced at compile time. So ones where you might have runtime checks, hopefully, but even then sometimes the runtime checks aren't enough because not everything is necessarily a success or an error state, right? Sometimes it's things that just do stuff slightly different than what you expect, which if you've ever worked with CSS, that's definitely the huge case. There are like no CSS errors, just stuff not looking like it should errors. And so this is for things like that. It's understanding the documentation about the behavior. And so my claim here is actually that documentation is the most important one of these three. And the reason why is that all software has some degree of inherent complexity. It's not really possible to get around this complexity. There's some minimum level that you have to be able to manage. And so any undocumented behavior is indistinguishable from a potential bug. If you come across something and you don't see, in the documentation why it works, then you have to spend additional effort trying to look in and figure out why it's correct or not. Working in industry, that's pretty much just the constant battle that happens. So you build software, you go and look at things, you see some weird result, and you have no idea if that's what the original author intended or not, or maybe it was what's intended, but now it should be doing something else because of other changes, and so on down the line. And so anytime it's not clear what the intended behavior should be, that's time that has to be spent determining, A, is it intended, and B, if it's not, how the heck do I fix it, and what other things might break because of that. And so treating that documentation is something that needs to be kept up to date and maintained, is super important. So the next thing is I want to do a quick example of the percent operator. I'm saying percent here for a particular reason, and that is in C++ and Java, this percent operator is called rem, or the remainder. And so if I have like 7 rem or %2, this is equal to 1. Similarly in Ruby and Python, this is called the modulo operator, and it does the same thing for these values at least. However, the difference between rem and mod has to do with negative numbers. So for instance, if I have -7 %2, in Java, this is the remainder, so it's -1. And in Ruby and Python, this is modulo, so we get +1. And so this is one of those weird quirks that you can run into very easily, particularly if you're doing this for various problems like bin packing is a very common example. A number of programs also ask you to just like modulo the number if you're doing like very big prime number operations or like very big computations. So you for LeetCode stuff, you would return that number mod something. And there are many other cases where you might be able to run into this. But the largest thing is that if you don't know what input you have, then you have to consider what happens if it's negative, and the behavior is different depending on what language you're using for this operator. So that's a main point of confusion. Very easy to run into into issues there if you're switching between languages and just not tracking that too carefully. Of course, there's many other issues like this. There are differences between languages too. In Rhovas, for anyone interested, the solution here is actually to not have a percent operator because it is just so ambiguous. The solution is just to use rem and mod as methods on numbers. And so now we get into the 3 design pillars of Rhovas. So, correctness, maintainability, performance. You're kind of seen this, but for sake of an example, I just kind of want you to think which of these is the most important. So correctness here being effectively, does the software work as intended? Does it do the right thing? Does it have the right behavior? Maintainability being, can the software be updated and changed over time, such as new features, bug fixes, whatever else? And then performance being, does the software work fast enough? So fast enough is kind of loosely defined here, but obviously some software has to run really fast. Other software, doesn't necessarily matter as much. So show of hands, who thinks correctness is the most important? Okay, a few. Who thinks maintainability is most important? Most of us, because we've all kind of seen this idea from me before. And then lastly, performance. So, okay, no one on performance, so which is good, yeah. As much as we like performance, yes, and the others. And so this is my claim, right, is that, as said, maintainability is most important. We'll go through and kind of justify this in the next slide. And so the claim here is that maintainability is greater than correctness, which is greater than performance. Let's start with these last two. So claim that correctness is greater than performance. If you have software that is performant but not correct, it just fails to achieve the desired functionality, right? Obviously, there's levels of scale of like how incorrect it is, but the short answer is that if you have a requirement or some type of bug in the system, that's a bug that needs to be fixed. And sometimes fixing that requires performance costs or whatever other changes. Or alternatively, there are some solutions that you could do to optimize performance, but that ignores other edge cases that you would have to deal with, and you still need to make sure those ones are correct. So those are things to consider. Alternatively, if it's correct but not performant, then it's much easier to work to improve that performance. You have a working version of the software. You can compare whatever your more performant version is against it, and then make sure that the two kind of agree on what happens. This is standard in a practice basically called fuzzing for tests. The general idea is that you use a very simple correct implementation of code, like bubble sort, some insertion sort. Insertion sort's I guess probably easier than bubble sort, but a very basic sorting algorithm. And you compare that against something more complex. Maybe it's merge sort if you're just kind of doing tests. But in the real world, you would probably have more advanced things like tim sort, which really get into dealing with changing the algorithm based on like the size list or dealing with patterns, and really trying to squeeze every little bit of performance out of it at the risk of very, very complex software. And this type of fuzzing technique has actually been used to find bugs in tim sort as recently as I think like 2 or 3 years ago. So it can definitely be very helpful. Of course, these are all ways that you can go from there to improve performance. Now, maintainability versus correctness. This is the one that's a little bit more controversial. But my claim here is that if you have correct but not maintainable code, then it's not going to be resilient to specification changes. So for instance, if I'm working on a normal kind of piece of software, most of the time I'm maintaining that software as it's developed and there are active users for it. And then most of my job is going to be dealing with new feature requests, new bug fixes, or sometimes just normal maintenance work that has to happen in order to keep running that application. And so over time, the definition of what is correct is going to change. New features are going to require changes to the code. Bug fixes that we discover may kind of invalidate what we previously thought was correct, and so we need to go through and fix that as well. And so all of these specification changes are going to result in us having to make changes to the code base, right? Even if the code was perfectly as before, we're still going to have to make changes. And so as a result, if we don't have maintainability, then we're not really going to be able to make those changes. We're going to fall farther and farther behind with keeping up with that scope of work, and there's less we'll be able to do. Similarly, if you have maintainable but not correct software, then it can be easily adapted to make correct. Right? So when we run into these specification changes, it's much easier to be able to get to a point where we have that feature implemented or we have that bug fixed, and then we can keep going through our normal software engineering lives. And then of course, this also makes it easier to improve performance. Right? If we have maintainable software, then any type of performance problems, by definition, it's much easier to make changes to the code base to add that type of maintainability. Now, I also kind of want to address, maybe I have a bullet point here. Yeah, here we go. That it still requires evaluating trade-offs for each scenario. The example here that I'd say is caching. So caching is a very common thing that we do in all kinds of applications for the purpose of improved performance. As well as kind of taking the load off systems and various other things like that. But it's primarily for performance. And so this is a case where we're going to be adding more complexity to things. We're going to have a larger risk of the software being incorrect. And because of that complexity and risk, there's going to be it's going to be more difficult to maintain that software too as a result of adding caching. However, we know the performance of caching, or the benefits from caching, performance being one of the main ones, but resource load being another one. is so worth it that we basically do it. It's also very helpful that caching is a kind of well-known, if not very hard problem. So at the very least, for simple applications, we have a pretty good idea of how to set up caching reasonably well for our types of applications. So that's a good case too. And so of course, I look at things like maintainability, correctness, and performance as, you have this hierarchy, but that doesn't mean you prioritize one necessarily over the other. Nor does it mean that you don't have to or that you don't sacrifice, say, maintainability or a little bit of maintainability or correctness for the sake of performance in certain applications. I mainly see this as kind of my guidance for when I'm building a language, because I'm focused on API design, for which maintainability is one of the largest key points for that. And so other things like that fall a little bit more into the application level. So as a quick example, here's some response error handling. So we've probably written code, we've probably written all of these variations of code really, but the very simple example is just we do some type of fetch operation, and then we get the response and we unwrap the JSON from it. Very simple, down and dirty type of implementation. We've all probably written like this exact sequence of code at least a couple times. However, a slightly more maintainable version of this, or one that's more error correct, or at least slightly more correct in the sense of being able to handle errors, is one kind of like this. First, we kind of get the response. We check to see if the response is okay before trying to unwrap any JSON, throwing an error if it isn't, just simple error, status text, nothing too complicated. And then finally, we might do something like return, say, the status code as well as whatever that JSON is. And we might return the status code because maybe they want to do something different or actually display it at some point. Or alternatively, instead of raising an error, maybe we just return the status code. And if the JSON, if the status wasn't okay and we don't have JSON, then we would return something just like null or undefined in that case, and let TypeScript make sure that we check for it down the line. And so this is something where eventually we're going to be probably reporting these errors down to users. So hopefully we'll have like a little error page for if something fails to load, or at least some notification for users. And then we'll kind of be able to better handle the correctness aspects of things there. At the same time, the left one, if you're in a highly volatile environment, like you're just kind of setting things up or trying things to work, or trying to get things to work, the left one can definitely be seen as more maintainable. I think there's a fair case for that. For the simple reason of it's less code, it's less complexity. We're not handling these error cases, but because of that, it's much easier for us to adapt whatever the code on the left is to whatever a particular application needs as we get those new requirements in. And so maybe those new requirements are, hey, we have to do error handling like on the right, and if so, that's great, we can do that. But maybe they're slightly different, and so we would have to handle it like that. Of course, the other piece is parsing. Right now we're just kind of throwing like arbitrary JSON data back, so it's probably be a little better if we were to kind of parse that into something and hopefully give that a nice little type that has information about what the fetch request actually should be returning. So yeah. All right, so last here is classification and paradigms. So Rhovas can basically be classified as a strong statically typed and object-oriented language. That said, it very heavily prefers functional paradigms. So kind of what I mean by this is things like structs over classes, basic simple data over relatively complex classes that have multiple fields to manage, may have mutable states, may have things like inheritance going on, or God knows what else. Other things like declarative over imperative, focus on kind of describing your code. This kind of just focus on maintainability, but in particular like reading or readability and then understanding, things like that. And then things like pure over mutating as well, kind of for the same reason as structs over classes, Mutable state is definitely a lot harder to track. At the same time, it's ultimately up to the developer to determine the right level of complexity for the given problem. And so what the example here mean is that, well really I'm just reiterating sentences but calling two things out in particular, One is that the given problem is very important, Depending on what type of issue you're dealing with, the software solution for that is going to be very different. That's just a very standard industry where a good chunk of what we do is very repetitive. We're building websites, or we're handling all this, or we're just hooking these things up to these things. But the part that's kind of the most important is really kind of debating, okay, what are the different approaches we can do these, and which one makes the most sense given the constraints we have. And so that's something that we have to consider as well when selecting a language or what type of approach we're going to take for sake of maintainability versus whatever else. And then the second one here is the developer, right? The developer word is super important because it really means that the team of people working on this is a huge factor in deciding what the best option is. For example, if I'm working on an application that's, say, in Java, or let's say Kotlin, Kotlin's a little easier for this example, but if I'm using a Kotlin application, then it may make a lot of sense for me to build some simple like command line tools in Kotlin, right, instead of, say, using like a Python script. For the reason being that if I'm already working with Kotlin, then I'm familiar with it, my team is probably more familiar with it, and it hooks into the other stuff that I'm doing in the project much better. So for instance, if I need my script to kind of grab something from this little thing or whatever, then I can do that because they're all in the same language. Likewise, I already have the infrastructure set up to use all of that, so that's a factor too. That one's a little bit more environmental. And of course, Python is a great option for scripting, has a lot of good tools, but if the team of developers you're with is not very familiar with Python, may not be the best option to go with that. So finally, competitive advantage is kind of our last main text slide. So the main list of key features in Rhovas that are centered around API design, these aren't exhaustive, but these are the ones that I thought would be kind of worth mentioning and discussing briefly. We'll see some of these examples here too. One is contracts. So this is things like defining preconditions, postconditions, and invariants. These are your specifications for your functions, your classes, and so on. One is mutability. So you're able to restrict the mutability of shared objects. So if I want to pass around a list, if I was in a language like Java, a very common thing that you see is defensive copying. So where I take the list, I copy it to a new list, and no one ever actually does anything with that new list for the simple reason of they didn't actually need to do any mutation things for it, right? And so this is defensive copying because you don't actually have a very clear contract, or even if you mention it in the documentation, that's not enough for you to rely on in order to avoid any type of unintended behavior down the road. So that's where this type of defensive copying kind of comes into play. And so you do get some performance benefits out of this, but most of it is really just making sure people don't make mistakes. Error handling is another huge one. One thing that Rhovas does differently than just about any other language I've seen, though other languages are kind of doing similar features to it, is to unify expected and unexpected error conditions. So the way that Rhovas does this is basically by taking exceptions and allowing you to convert exceptions to result types and result types to exceptions. If you've never worked with like a functional language, a result type is basically some value that is either a success or an error. And so this is a very easy way to move back and forth between these two. Other languages have some helpers, and normally they use like result types. And if you call a function or like do something, it says, oh yeah, if this was an error, we're just going to return that error to whatever current function is. And it works very similar to an exception in that regard. Rhovas has effectively the same type of thing. API compatibility is a huge one. This is a very complex topic considered, and it's probably the thing I'm researching the most right now. This is basically a way to identify API breakages and perform migrations. So if software does change, then you're able to update all of your applications with whatever new library code or whatever else is happening. Very simple example is if I rename a function, over time functions will kind of change in behavior. Sometimes it would be very helpful to give them a new name. In many cases, I think like the old kind of C libraries where like there were these abbreviations. We've since learned that like the names are just kind of wrong at this point by now because they've changed the behavior so much or have got stuck to a point where the names are just incorrect, but we can't change them. And so renaming things is relatively easy for a static language where we know what functions are being called. But more complex things might be like really redesigning library calls or like changing different types of arguments or whatever else is going on. The more complex you get with it, the more unlikely anything like this is going to be easy and safe. But for simple things, it's possible, and that would go a long way to helping with maintainability across dependencies. And then lastly, embedded DSLs. We'll see an example later, but this is effectively the idea of just use the best language for the problem at hand. Right, so the example I gave was scripting stuff. Kotlin has, some scripting things, but at the same time, it's not really something that you can that easily just say, run this Kotlin file from the command line. So if that's something where it's like, hey, this isn't just for my use or for developer use, this is something that I want to pass around to other people, or like anyone who downloads this repository can run this, from the start and get some good behavior out of it, then maybe it is worth trying to do that Python script instead. And then I want to be able to work with, things in there. And so if you have embedded DSLs, then you can use the best language at hand for that. Python script, one example, probably the most standard one is really just like SQL, right? If you're doing database actions, the way you communicate with that database is through SQL. And so if you could just write normal SQL queries instead of, weird strings or ORM stuff, that could help in a lot of situations. Doesn't mean it invalidates the use of an ORM, but it gives a good alternative that, helps a lot. And so note, these are all in various stages of being implemented. No promises that any of these things totally work. And of course, we'll do the best that I can to kind of get it working, but we'll see, hopefully at some point. Help wanted. So if anyone's interested in writing some Rhovas code, I guess, I guess writing Rhovas code would help, but the compiler's in Kotlin. So if you want to write Kotlin or Rhovas code, see, 2 options now, then please, by all means, could use help with it. And so that brings us to the end of kind of the core presentation. I'll throw out some various examples in that with whatever time we have remaining. I have a couple examples just showcase different, language tour features of things. But as far as content so far goes, if anyone has any questions, feel free. So yeah.
This work, why do you choose Kotlin to write it in? It seems like a lot of languages that I've seen, they're typically written in lower level languages like C or C++.
Yeah, just repeating for the recording. So why did I choose Kotlin as the language for the compiler as opposed to, say, like a low-level language? The main reason is development speed. One is that I am very familiar with Java, JVM languages. Kotlin was kind of a natural thing that I was roughly picking up around that time, and have since kind of largely learned through my work with Rhovas. But Rhovas is also very similar to Kotlin. And so long term, the idea is at some point to eventually take Rhovas and write the compiler in itself. Right? It's much more feasible than might seem. It's also much harder than it might seem. And some of the reasons it's harder is that Kotlin has another key benefit to it, which was one of the main reasons that I migrated away from Java, which was that Kotlin supports targeting both JVM, so I can run it as like an application, and it also supports targeting JavaScript, which is how the online editor works. So without Kotlin's support for JavaScript, then the online editor wouldn't really be a thing. And so that was kind of the other really large selling point at that time. Yeah.
So how often how many times since you started developing this language did the language specification change?
How many times does the language specification change? I don't know, like every time I write a line of code, pretty much. So I had a separate repository that I used to manage like the specification. The idea was that being able to do that documentation would help me be clear on what the intended behavior was. I also wrote a lot of very comprehensive unit tests for it. I've since kind of fallen off of both of those, primarily because you said like the specification does change a lot, in particular as I learn new things and come up with new ideas or implement features that I hadn't gotten to yet. But also as I start discovering stuff that didn't really work how I thought it would, or had other problems with it at that point that I wasn't really prepared to handle.
Would you rather have gotten it right the first time, or are you just happy with how it's turned out so far?
Would I prefer getting it right the first time? Yes. Am I happy with how it's turned out? Also yes. So I mean, I think the largest thing right now is I am continuing to work toward adding more tests into the system. I'd fallen off that primarily because once I started supporting JavaScript, I found that the majority of errors were on the JavaScript side because Kotlin's JavaScript support was questionable, to say the least. I was running into a number of really weird things, including one where defining an interface but not using it resulted in lists becoming a subset of token types. Yes, I know that sounds absolutely insane. I don't know, but I replicated it multiple times. So it was things like that where I needed as many more tests on the JS side. So one of the things that I started doing, actually, is I shifted over to basically just building a bunch of example programs. And I think I'll show a little bit of that here at the very end, too. Maybe like 1 or 2 questions. Yeah?
How long have you been working on this for?
How long have I been working on it for? A little less than 5 years. They wrote us July 11th of 2018.
Oh, that's right, you said that.
Yep. And yeah, last question.
What are some of the advantages you might be sacrificing by choosing Kotlin to be the bootstrapping language?
So what would I be sacrificing by choosing Kotlin? Short thing is that I think it's pretty much what I've said previously. This part, it's mainly I'm going for development speed, but that comes at the cost primarily of performance. But at the same time, I'm building an interpreter, not a compiler. If I was building a compiler, then it doesn't really matter as much unless I'm worried about compilation times. But I'm not anywhere where compilation times really matter either. So like the interpreter is slow, Kotlin is slow, it's all just slow, right? Performance may be one of the big things, but correctness takes priority, and right now the language barely works. So it's building that type of things. And a large part of that is I am learning how to build a language, right? This is not something that I've known how to do. There's a reason I've rewritten the compiler multiple times, 5 or 10 iterations at least. And that's simply because I don't know what I'm doing for a lot of things, right? I don't know what option is going to work. I don't know, where the complexity is. So I start with something, and then I have to be able to quickly change that and get it to work elsewhere. If I was much more comfortable with, say, C++ and I really knew the language, maybe I would have picked that, but that wasn't where my own experience was, right? So that's another case of where, given problem, yeah, but also the developer, in this case me, right? I needed to pick a language that I knew and I was comfortable with it. All right, very, very last question. Yeah, do you have one?
Oh, yeah. So what's the use case for Rhovas? Like you mentioned, contracts and APIs. It's like a web server type.
Yeah, what's the use case?
Yeah.
The largest thing is all the API design features really lean themselves toward library development. So if I am building a library for other people to use, then I want to have all of these features to make my job as easy as possible. The natural consequence of this, however, is that if I am building an application, then I want to work with libraries that people have done a very, very good job building. And so the end result is it's very hard to say that it's for anything other than general purpose, for the simple reason of that the specific problems that I'm trying to solve are problems that apply generally to all of software engineering, namely things like theory of software APIs, problems with assumptions, and that type of nature. All right, cool. I'm going to move into some of our examples here before I run too far out of time. So let's do that. I think, yeah, language tour. Showtime. All right. So I've got a handful of examples. We're going to mainly start with just kind of basic syntax structure. I'm not going to try to go too exhaustive. The documentation on the website is there for anyone who wants to take a look at it. But just show off a few of the various fun things that just kind of make Rhovas Rhovas. And then maybe at the end, y'all can tell me things to do, and then we'll see how long it takes the compiler to break. So we'll see. All right, anywho's, let's go. So I'm going to open this up to maximize that. Also, for reference, this is just rovas.dev. And everything here, for instance, this has the pillars of language design, some information on that. So most of the content of the slides are all here. So over on the editor, I don't have to write this one, which is great because it just kind of gives us to it. This is FizzBuzz, right? We've all kind of seen FizzBuzz before. It's a very standard, print numbers. If it's, divisible by 3, do one thing, divisible by 5, yada, yada. So we can see we have a working FizzBuzz. So that's always nice. But we'll take a kind of little bit of a deeper look into how this works. So the first thing is this range function. So we have a range from 1 to 15, and we're told that this range is inclusive. This colon thing is called an atom or a symbol. It exists in a number of languages, particularly more dynamic ones. I stole or adopted it from Elixir, but they're very handy for kind of representing very simple constants. You can think of them as basically like unenforced enums, in the sense of anytime you see a symbol, you're kind of expecting hey, this is one out of a relatively limited number of options. So in this case, inclusive is one of them. You can probably guess the other one is exclusive. But we use inclusive here basically to make it very clear that this is 1 to 15 inclusive. If you had like exclusive ranges, like in other language, you might have something like 1 to 16, which is much harder to tell what's going on at a glance. Similarly, like range from 1 to n, right? So there's different combinations. Some languages go as far as to have separate syntax for inclusive and exclusive ranges. This is our current solution. I don't know if I'm going to stick to it, but yeah, we're going with. Yeah, question.
So how did you make the choice for choosing a truncated word to represent inclusive and exclusive? What was the advantage of using a truncated word instead of the AP verbose version?
It's faster to write and unambiguous in context.
Unambiguous in context.
That's really all. You could even do like I, but that's much harder to tell. What you see inclusive and combine it with the range, then good enough. I generally prefer to avoid any type of abbreviations. So that's a good call out. This is kind of one of the situations where it just kind of happened. I don't know if I'm going to try to standardize, my thoughts on abbreviations, but I do think, like for instance, like I'm using mod over modulo here, and that's because mod is very well known to be the modulo operation. There's not really an ambiguity then. Similar like math.sqrt for square root, it makes more sense than spelling out square root, right? It's sticking to convention. Right? If I don't have a compelling reason to break the convention there, probably not the best idea to do that and make identifiers longer for the sake of clarity that actually doesn't exist because people already know what it means in general. Yeah, another question?
So like val is implicit from the for loop, I'm guessing?
Yes. So let me change this back to 15. Val is the argument that is coming in from this for loop. This is actually, fancy things, this is what I call a functional form. It's implemented basically just as a little function with a lambda, but the idea is that when you start trying to chain operations, there are a lot of different cases where what you really want is just chain x then y then z and so on. And if you start mixing in like statement keywords like ifs, fors, whatever else, it becomes a little bit more unwieldy to work with. So Rhovas has a number of support for like keywords that kind of go at the end here where you can do things like that. You can use like .if. It's a little bit weirder, but well, I guess I can just show it. If I just print, let's say 1.if, let's say val is greater than 0. I'm using parentheses here because due to a quirk in the current implementation, without these parentheses, it thinks you're defining a variable. So something for me to figure out later on. Well, not figure out. I know what to do for it, but I just haven't done it yet. So you'll notice this prints out 1. This is the one from this one. Maybe it'd help if I'd say like 100. So there's that 100. But if I say like less than 0, this will actually return null. Kotlin has a helper called takeIf, right, which says give me the value if it meets this condition, otherwise return null. You can do that. So like that's a case where you would then start chaining things from there based on what you need to do with particular values. It's messy, but if you've worked with that type of structure in Kotlin before, it actually is a little bit more natural than you might think. Yeah.
Where's the value for val coming from?
In this case, if, right? Because this is a lambda. So these braces are lambdas.
Okay, so val is 100.
Yeah. Alternatively, if it would help, I can say like x, right? If x is less than 0. Well, we'll flip it because the output's the same, so you can see it. But yeah.
I see now.
So yeah. Yes.
So like the 100 or like whatever expressions come back, is that evaluated whether or not the if statement runs?
Yes. So because this is all on the hand side. So this is for like so this is evaluated beforehand. Just general question. So this might be like for instance, you can do pipelining. So if I wanted to do well, let me do it here. So 1.pipe range. So this is the same thing as passing the first argument, right? You can see if I were to, let me comment this out. So you can see this works the same. This is pipelining. The general idea is that when you're doing this type of chained operations, right, this may not be 1. This may be like, list.size or something like that, or maybe some other computation. So if you've seen the builder pattern where you're doing all that kind of chaining stuff, it's very natural for you to do things like this as well. For instance, you can do some other, let's see if this will work. I don't know, I didn't test this. Rhovas has a thing called a cascade operator. This is from Dart. If you do ... and then call a method, it will return whatever's on the left-hand side. So I think if I pipe this into print, then I think it should print 1 and then go and do the range. It does. Okay, I'm mildly proud because I did not actually test that beforehand. So yeah, so that's the basic idea, right? You have all these operator support that you can use to support chaining things. Part of that is there's a catch-22. Defining more variables can be helpful for knowing individual pieces, but can also make it less clear to understand the data flow through an application. And it can also make it very confusing because you see all of these variables and it's not clear how those are being used. Like if I see like 5 variables at the top and it's all like the first one like just goes into the next one and the next one and so on, I'm going to get to the bottom chunk of code and be like, okay, were any of those variables needed? Do I have to be looking for them? Or like were the values reused or whatever else? So that's something that gets confusing to me. Part of that just comes from a lot of experience and familiarity with like the more functional way of writing code. So obviously, like you don't have to do this, but the tools exist because I think it's very helpful for the readability there once you're used to it. But having written most of the compiler in Kotlin, I've been using things like this for a long time. So yeah, cool. All right, let's go on to the examples here. I did want to call out pattern matching. So this is pattern matching. It is a feature of a lot more functional languages where basically you can match on particular values. Rhovas has some fancy support for like all kinds of crazy things you can do with patterns. I'd love to show off, some of them, but let's see. I just want to change this back to just 1. But there's like all kinds of things you could do. For instance, you can do like varargs and just say else, like if it's any list. This is vararg, so this should work exactly the same. And then there's various other things. You can apply patterns to varargs, which is something I've never seen used in languages before. Maybe it's worth just like kind of showing that. I won't show it because you need next structure for it, but if someone's interested, I can show them at a later time. Okay, so I want to reset this, next thing, which is structs versus classes. And so Rhovas has both structs and classes. If you've used C++ before, you've seen both of these keywords. However, it's very unclear what the difference is between them. The answer is just the default visibility. That's it. Rhovas is very different. Rhovas has structs, which are basically just plain old data containers. So if I have a struct with var x, which is a decimal, and var y, which is also a decimal, so it's a simple x, y vector, then I can kind of make this thing. So I can say val vector, new vector, and it takes x, which is 1.0, and y, which is, let's just say also 1.0, and maybe 2.0, just for clarity of difference. And then if I print vector, you'll notice we get this vector printed out, right? X is 1.0, y is 2.0. And we actually get this, we get all these kind of things is very clear by virtue of it being a struct. We can print out the x components. We can even assign to it because they're variables. So say like vector.y equals 10. I'm not printing out the whole thing, but this is not, well, it doesn't have a semicolon, but this is also not a decimal. That's an integer, right? Decimal.y requires value. That's a bad error message. That should be printing the vector struct. But this should be a decimal value, right? Yeah.
Just wondering, when you write decimal, is that referring to a base 10 decimal or an IEEE float?
A decimal number. So that's a good question. So right now in Rhovas, there are only arbitrary precision types. So the integer is basically a big integer, and decimal is basically a big decimal. There's various nuance here related to exactly how the precision works, particularly for decimal where rounding is involved. But that's a problem that I haven't spent too much time on solving. It's an important problem to solve, but I haven't gotten to it yet. So the more likely plan is that like you will have to do something like float.64, right? 64-bit float, right? Obviously this looks a little bit more weird for like decimals and floats, but for ints, much more standard. And this is very standard. A lot of languages have started doing this type of thing where you just say the number of bits rather than like ending up with like a long or whatever other type of nonsense. Another question? Yeah.
When you say val vector, like when you define it, is the val like the same as the auto keyword in C++?
No, that's actually why I had to put parentheses around the thing, because val is both used as the implicit argument to a lambda and the start of a variable declaration. That's an easy fix. I just have to basically say like a variable identification is like that and an identifier. But it can be a little conceptually confusing at a glance. Part of that is where IDE helps. Part of that is like better language design, right? I thought val was nice as a reuse of keyword to avoid too many restricted keywords in the language. Kotlin uses it, for instance. That's not restricted, it's just there. But maybe there's a better way of doing that. I'm relatively happy with how it is at the moment, though. We'll see. Yeah. Val can be used as that lambda thing because you can't change the parameter of a lambda like that. You can't reassign to it, Felicity. But var is mutable. This is basically equivalent to like, x, and then a val, right? If it was val, this is final, right? That's the only difference there. Let me keep moving this example. So we have this vector. Now we can add methods onto it. So for instance, we can have a magnitude. And so the way functions work, or methods work, is that the first argument to any method is whatever this is, right? In this case, it's a vector. So you could do this vector, but Rhovas is slightly more advanced than what it could be for simple demos. You can just write this, right? This is very similar to like self in Python or various other languages. There are implementation reasons for this. It's something that I've looked at and considered changing at some point in time. But many style guides in Java do actually require you to put this before like any instance thing that you access, just to be able to keep track of like what things are instance methods, what things are functions, what things are this, that, and the other. So there's a certain like logical reason to do so. I haven't really thought much about whether I want to enforce this at some point or eventually allow other things to be used, but this is how it is at the moment. And so magnitude of a vector is math.square roots of this dot x times this dot x plus this dot y times this dot y. Right? And so if I print vector dot magnitude, you'll notice I don't need parentheses around this. Here's my semicolon. Where is my semicolon? Let's see. Float dot, yeah, this does not exist. Let's change these back to decimals. Decimal. Cool. Okay, and I need to give this a return type. The return type is decimal. Cool. Right. Let's change this to 1 because we all know what the square root of 2 is. Right, square root of 2. 1.414. Cool. You'll notice this in parentheses. This is just kind of another implementation quirk. You can define properties in the language just like these, x and y. And so, magnitude is probably a fine property because it's not like doing super complex heavy work. But, in general, using parentheses for things that are like actually computing methods, probably a good idea. Both do the same thing. Yeah, question?
Did you mention something earlier about how you can write functions in a way to enforce contracts?
Yeah, can you write functions in a way to enforce contracts? Yes, you can, and that is exactly what we're about to do.
Okay, yeah, because I'm very interested in that.
So, bear with me. This is a little bit of, one other question.
I didn't want to stop you while you're in the middle of that next part here. Before we hop onto that, what was your design decision around using or requiring the definition of this keyword when defining a method? Wouldn't that be implicit in the fact that this is a member of a struct?
So why do I require this? Wouldn't it be implicit? Well, let's say I wanted to do a simple test function, and I just say print test. I can do something like just vector.test, right? And so this will print out test, right? So I can call methods, on the actual type, and these are just like stat functions, right? There is a thing in programming languages that is called uniform function call syntax. It is basically the idea that something like object.method is the same thing as method object. There are various reasons of complexities that I don't go through and do this entirely. That's part of the reason why I have pipelining in the language. Pipelining can help with situations where you would want to use this type of new methods or new functions to just chain things. But this is uniform function call syntax. The way that the lookup of methods works in the compiler right now is it does not differentiate between those scopes and relies on this uniform function call approach and the implementation to figure out what function you're referring to. So when you call something like vector.magnitude, it says, give me the function on the type of vector, which is also vector, that takes a first argument of whatever the type of vector is. This is actually very interesting for a lot of different reasons, because this is what allows you to make functions that work differently depending on things like generics, right? So for example, if I had a function definition that was like, sum, and it took a list of integers, right? So like this is a list of integers, right? And it returns integer, right? I can't write this because I don't control the list interface right now, but I could define this in the implementation of the compiler. It is smart enough to recognize that this does not have to be any list, right? It can be a particular subtype of list, in this case, a list of integers. And so there's a lot of powerful things you can do with it. I'm just not really leveraging much of them, so it's much more of like an implementation artifact. But it's a fun question that's like implementation detailed. It just doesn't have much impact on the language design at the moment. Yeah,
Kind of related to, I guess, kind of some classes. How are you planning on handling exports for things like private?
How am I planning on handling exports? Yeah, I haven't spent too much time on this yet. That's one of the next things I have to get through. You can't even run multiple files right now. That's still a work in progress. So, exports at that point, kind of a little out of sight, out of mind type of thing. I've looked into various ways of doing things, but I definitely want to be cautious with going like too many keywords and stuff, and too many different nuances of things. So I've thought a lot about it, but I don't have anything coherent to say right now, I would say. Yeah.
How do you approach memory safety?
How do I approach memory safety? I don't garbage collection primarily. The work that I'm doing with mutability, what I've actually found is that, that's found. It's more of like, once you make the connection, it's very obvious. But when you're starting to mess around with like mutability and understanding what things can mutate what objects, you notice that there's a very clear overlap with ownership, with memory ownership, memory safety, memory borrowing. And so the end idea is that at some point, it is in theory possible to intersect those systems, but it's not a clean intersection, right? Like it's not as easy as like just add both and they both kind of work. So it's a very weird mix of, in theory, it could be very easy because some of that work is already done, but also the fact that some of it already exists means that the overlap may not be very clean, right? Because you might think it works in one way, but then it finds out you have to split up some other cases down the road. My general opinion on this, and I think I call this out on one of the docs, is that there are other languages looking into the problem of memory safety that are way better than mine. Veil and Cone are the two main ones. I talk with the language developers for them like a lot. So I ask them questions about memory safety. They ask me questions about APIs, right? So basically, like I would say, like, look those languages for anything sophisticated happening there, because that is not my area of specialty. So I haven't worked with, a lot of memory managed language that much. Yeah. Question? Yeah, go ahead.
So is magnitude, like the calling convention for the property for magnitude, is the same with or without parentheses, but you can't return a function type as a property. Like it's just implicitly calls the function. Like you can't have a property that is a lambda.
I see what you're saying.
Yeah.
You could, for the simple reason of you cannot just put parentheses after like an arbitrary expression to run it. It will still like look to try to call a function. If I was, then I would basically call invoke. This is how you would do it right now. Further down the line, dot and then just the parentheses might be sufficient, to be determined. But yeah, so it wouldn't be an overlap, you just wouldn't be able to use that syntax. So you'd have to use one of those two syntaxes. And yeah, you had another question?
I have a question about something you talked about earlier, about piping the first argument into your builder expression. How would you pipe the second argument?
So you could pipe the first argument, how do you pipe the second argument?
Or the end argument?
Yeah, if you want to do like arbitrary piping with stuff, there are a number. If you're interested in piping stuff, there is a proposal for JavaScript to look into adding pipelining to the language. That has a lot of stuff on it. And they have like some various options of how to possibly do that. In general, it's something like one pipe, and then you do like print, and so like, you know, some symbol, right, to identify like which place the argument goes or whatever else. In my opinion, they're not very clean. 90% of pipelining is the first argument. Leave it at that. That's my current thought because I got other problems to worry about in the language. Let me pause there. Let me get through and finish this example here too. I got examples. So I was looking for an hour. I think this is going to be close to an hour and a half. So let's try to get through these. So this is a little bit contrived, but for sake of showing off structs and classes, imagine that I had a class that was a unit vector. Or let's say it wasn't even a class yet. Let's just say I wanted to represent a unit vector. If I did so with a struct like this, then I would basically be dealing with one. I can't use this one because it has mutable units. Right? Now I could set it up such that I could take the unit vector in as an immutable one, but there's nothing to enforce that this vector is ever actually created where it is a valid unit vector. Right? The most important thing about a unit vector is really that it's not zero. As long as it's not zero, it has a direction. Right? So you can at least say like, okay, we can take a vector, as long as it's not zero, then we can from there. But, you know, so there's other opportunities, but let's just say we're going to define this new unit vector class. We're making this a class because we want to define a custom instructor that enforces this invariant that it has to not be zero. Right? And then we're going to do the additional math work to basically just make sure it has the right x and y. And so let's start. So we're going to make these val x, which is still a decimal, and val y, which is still a decimal. We're making these val because we don't want x and y to be modified afterwards, right? Because if they were modified, then you have a chance to break the invariant, which is that you know, x squared plus y squared is equal to 1, right? I mean, square root of 1, but square root of 1 is 1, you know, or 1 squared, I guess. So anyways, so now you have an initializer, so init, and then this is direction vector. Initializers are a fun separate topic, but you know that we'll see that here in a quick sec. So first we're going to require that direction.x does not equal 0, or direction.y does not equal 0. And so this require is a precondition. This is a precondition that can be checked at runtime or could also be disabled at runtime depending on what you want. Think of them like assertions, just it uses require instead because it's specifically a precondition assertion. And so the idea here is that we want to say that whatever vector you pass in cannot be 0, 0. Right? If it was 0, 0, then it wouldn't have a direction. The direction would basically be implode into a black hole. Yeah. So will it throw like if it evaluates to false? Yeah, it's just an arbitrary condition. It's like assert in most languages. Yeah.
I'm sure there's a very good reason for this, but why is this better than, say, just doing an if statement at the beginning of a function and throwing an exception if this is not followed?
Right. So why is this better than just doing an if statement exception? So first is we're defining a new type unit vector that can be enforced statically. The runtime check to create this unit vector, you know, or the check to create this unit vector, this is still enforced at runtime. But you might have one place that like creates the unit vector and then many places where that is used. Where alternatively, every single one of those places where it's used would have to validate that condition before doing math work that would otherwise throw like a divide by 0. And a more sophisticated thing, you could basically do something like, you know, type unit vector, right? I'm getting ahead of myself here, but is like a vector, where, this dot x does not equal 0, or this dot y does not equal 0. That makes sense? Right, so if you know that the vector contains at least, an x or a y that's not 0, then it has type unit vector. This is a higher level idea, so I'm not really going to talk about this too much, but just know that it exists and they're all alternatives, but I'm showing you this with a class for sake of example. So anyways, now we're going to get the magnitude. So magnitude is direction dot magnitude. And then very lastly, we're going to invoke the constructor. And so the way we invoke the constructor is this, right? So this with these braces. And x is going to be equal to direction dot x divided by magnitude. And then y is going to be equal to direction dot y divided by magnitude. Let's make sure that we can run this. So val unit vector is equal to unit vector, vector, and then we're going to print unit vector. It's definitely hard to type while standing. Cool. Okay, so you can see in this case it's just 1, 1. But of course, when 1 is not a unit vector, it's just a vector. But the unit vector for that is, of course, like e minus 1. So this is 0.707, which looks right. Yep. So yeah, a question?
Could you demonstrate what happens if you actually put in a 0 vector?
Yes, I will. So let's say we put in a 0 vector. We should get a failed precondition assertion, right? Our arrows are a little off, but it says this precondition assertion failed. There's more that can be built to with like actually printing out data and other various stuff like that. That's a whole wild concern because it is not trivial to print out arbitrary data for error logs because of, let's just say, like simple example is like the object may not even have a reasonable toString, right? Like think Java, for instance, right? Like if you just try to do that, it just won't look pretty. Other concerns might be like PII, right? Like personally identifiable information, right? So depending on the situation, like generalizing that is hard. But over time, we definitely want to get to a point where if you fail a requirement, then the error message is as clean as possible, and that it can like clearly identify exactly what went wrong. At least in this place, it's pretty clear, though hopefully you have enough things from external to the system where you can be able to reproduce the situation.
What exactly was this error generated in the process of like clicking play? Was it like before running the
Yeah, so where did this error come from? This came from the evaluator, right? Eval. Yep. Actually, this is from something slightly, I don't know where this is from exactly. I think it is, but this is from the evaluator, right? We have a whole stack trace of what's going on, right? And we can see this came from like our unit vector class, right? Now train of thought on this constructor here. So this is one of the weird things. I haven't spent that much time really exploring this, but I implemented it for the heck of it because I thought it would be cool. But the idea is that you can pass effectively a struct initializer to this. And the way it works really starts mattering when you get into inheritance, because with inheritance, you have to initialize parent objects first. And one of the risks of initializing parent objects first is that if the child object hasn't like set fields and you call like an abstract method, then the child class could just blow up as a result, right? Because you call an abstract method, it goes to the child, but the child hasn't even finished initialization first. So that's one of those weird like API hypothetical experiments that I'm looking at. And so without going too much into detail, this is the general solution idea because it allows the child class to make sure that the fields are initialized at the very least. This doesn't necessarily protect you against like logic errors that can occur down the line, but it's more for like memory concerns with like say seg faults or whatever else farther down the road. Okay, cool. Any questions on this? I've got 2 more examples, so we're like really running out of time. Okay, yeah. Yeah, sure.
So suppose I write a function that that accepts a vector, and I decide that I want to make it so that this function only accepts, like it requires that the vector be a unit vector. what would be a good approach to like writing that function? Would I actually just change like the parameter type to unit vector, or would I write this require statement with like a long condition? For,
Yeah.
for
So
testing if it's a
yeah, so how do you approach enforcing this statically? At this point, if you have a class unit vector, same as any other type. In general, you would have this type of requirement, right? And that requirement could be as sophisticated as you wanted it.
Okay.
So yeah, a question?
What was the design decision to put the generic constraints so that they require direction that x isn't
Mhm.
0, for example? What was the choice, the design choice behind putting that within the actual body of that method and not instead outside in the signature?
Yeah, so there's a couple different thoughts right here. One is that these are enforced at runtime, really at the moment. That was kind of a huge factor. Another was effectively figuring out just good syntax for it. This seemed to be one of the better options, particularly because it relates back to assertions. So the way it works with assertions, stuff like that, is the same. You can also pass messages. Is it like this? I forget the exact syntax. Message, say like direction, if we were to include the direction. Let's see. Yeah, message. So here we go. So we can see that's the vector, right? So you can print it out like that. So that's kind of another reason why, right? You may have more sophisticated logic kind of going on. The other reason is actually because of its counterpart, ensure. So if I have like if, if like, let's just say if true, right? I might have return this, and then I might have an ensure here. Else I might have, return this and ensure this, right? And so this is a way I can build post conditions depending on which different case that it went in. If they were structured at the very top level, you would get top level assertions, but not case assertions. And so what is very likely to happen is that you won't be able to just put, general preconditions or even post conditions or whatever else, like right at the top or the bottom layers. Right, they're going to depend on other conditions or maybe even environment stuff every now and then, and so their purpose is not to statically enforce things, though obviously that is, as best as we can, the goal at some point. Their point is to make it blatantly clear if it's a require and the require failed, the caller's at fault. If it's an ensure and the ensure failed, the implementation is at fault. That's the primary purpose of them compared to a general assertion. So yeah. Okay, cool. For sake of time, I'm going to keep moving. I got two other, relatively quick things. We'll see if we can get them done in like, 10 minutes or so. Let's see. Okay, so the first thing I want to show is relatively straightforward, which is just error handling. And so let's say that I have a number and I want to, or a string that is a number, and I want to convert it to an integer. I can just do so like this. So you can see this is 1. So the way this works is actually via first class types. And then 2 is one of those weird functions that's actually defined as basically 2. And then it has, argument, or, the type is basically the type of integer. Right, so this is pretty much the way it works as a rough mess. So yeah, so you can convert this to an integer. You can see that prints 1. If I had another thing, let's just say like a.toInteger, what happens? We get null, right? And the reason we get null is because 2 for integer returns a nullable response. It is either the value if it is actually an integer, otherwise it's null. And so this is something where you can go through and check to see. You want to make sure that you check if it's null, handle it from there. And so now the question is, what happens if we know that it's actually accurate, right? Well, let's see. So first off, if this 2 integer, right? I said this returns a nullable response, so we can see that if I try to just like add 1. You'll see undefined method. The method nullable integer is not defined, right? .add is not defined simply because it's a nullable integer, not an integer. So if we wanted to assert that this was present, we can use an exclamation point. And the exclamation point here means that this is a function that can throw an exception. Right? Rhovas supports being able to convert between exceptions and result types automatically, as mentioned. And so the end result here is that this should just work, right? So you see we get 2 back. So we got a nullable type. We assert it. Well, technically speaking, there was a nullable type. It was automatically asserted by internal compiler mechanics. And so this whole function just returns 1. And then we add that to 1. It's simple enough. What happens if we do that down here? You can see we get uncaught exception, right? Our error message is a little off here. Really, it's this. Still work in progress. Error messages are hard. But you can see we get an uncaught exception, right? So this is an assertion of what should be happening there. So we might do something like this. And then one of the other things we can do is that whole functional form thing I mentioned, right? Like putting .4 at the end. You can do that to just basically put a block of statements here to do other things. And so the way we can do that is you can use a question mark. Simple one, let's just start with simple. So I can do like .add one. So in this case, this is null. But if I change this to say like 3, there you go. Right, so that question mark is very similar to how it works in JavaScript and most other languages. But I can also do something like .do, and then of course parentheses because of parser limitations. I need to go fix that. And then say val plus 1. Right, so this will still be null, but if I change this back to say 3, then we get 4 again. So yeah. And so all that just goes through. Other fun things you could do, I guess. What happens if this is like an invalid format, like 1.0? That's just more of like things, but you'll notice this one is still null. Another fun thing is that this will support hex. So we get 256, right? FF is 255, and then we add 1 to it because it was successful parse. Yeah, one other question?
Yeah, so I noticed your use of the nullability coalescing operator here, the question
Yes.
mark.
Yeah, no coalescing.
So what was the design decision of having implicit nullable items instead of explicit nullable items?
What do you mean by implicit null items? So I think what you're going to say is that, like, is it clear that this is nullable or not, right?
Yeah, so does this paradigm, this nullability paradigm, is this default across the language, or is it only select pieces that are default nullable?
So yeah, so this defaults across the language. So this type of nullability or result to exception and back and forth applies everywhere in the language, right? And so the reason why is because it's for these types of chaining things. So if you have expected errors, right, you're probably going to be handling those most of the time. And so you want to be able to very easily say, yeah, we expected it in this case, do this, right? And so you don't want to worry about exception stuff. Right, the point is not to like build these complex try-catch hierarchies to deal with all of that. It's to just kind of say, yes, we expect this to fail, and in this error condition, we do that. Right. So for example, we might do something like to this dot else, just say 0. Right. And so if this is say invalid, like this should be, then we just default to 0. Right. And maybe that's acceptable depending on the application you're working with. Right, it depends on an individual use case. But this is much easier to work with for this specific example than saying trying and catching exception types or whatever else. In part because you know exactly what method that you're dealing with, right? This isn't something where like anything in that try-catch block, could have happened. It's this. Of course, even if you're in a try-catch block, then it's much clearer the only things that are throwing exceptions are these bang functions, right? So I think it's as explicit as you could possibly get, far more explicit than exceptions than any other language. Yeah, other question?
Yeah, so you turned like the ICE from the do and the else, so it's like everything in expression.
I would love to. Yeah, so like is everything expression, including like if and else and other stuff. I tried that, didn't quite work. I will be returning to work on that at some point. There's various weird quirks about how to set that up as well. And so I hacked a good chunk of it to get an implementation, but I wasn't really happy with it and it had some other quirks. But long term, that's the goal for the simple reason of there's no real reason to do anything else per se. I don't think I'd encourage it that much. I was much more skeptical of it, like, statements as expressions when I started. But having worked with Kotlin much more, I've gotten, a lot more comfortable with it. So yeah. Okay, we're going to go on to the last example. And this is the fun example, which is embedded DSLs. right? So embedded DSLs are being able to kind of put other languages in things. So let's say, for instance, we had something like val language is Rhovas, right? That is our current language that we're working with. And we wanted to basically get all of the juicy information on Rhovas. And so we wanted to pull that out from SQL. And so we're going to do something pretty easy. Select star from languages where name equals language. So the syntax highlighting isn't great here, but this dollar sign, brace thing is effectively saying interpolate the value of language into this query. And so the end result is you'll have an SQL query that is safe from SQL injection because it is not mixing the value of this language string with the actual syntax of what's happening in SQL. So I think I'm going to need a semicolon here, but let's run this. Undefined DSL transformer. So it identifies something's going on, but it requires a transformer function, list string. It's saying list dynamic because it doesn't know exactly what type the arguments are, but we can do it like this. So we'll define that function, not like that. Function SQL. We will do literals, which is a list of strings, and then arguments, which is a list of anything. And just for simplicity, I'm just going to print the literals and print arguments. You might recompile this into a prepared statement or whatever else like that, but that's not the point of this example. The point is just to see how this gets transformed. So now if I run this, you can see here's our literals, right? So I have select star from languages. I have a new line because our original source had a new line in it. And then where name equals, and then this comma, which means that there's two arguments here. Right? The second argument is blank because there's nothing after this, but there's still an interpolation, right? So the right-hand side of this interpolation is an empty string, basically. So that's why that shows up. If I show like here, right, then this is a little bit more visible. But yeah. And of course, the argument is Rhovas, right? And so you might, fix this up by doing something, like return prepared statement. Literals, arguments, right? And so then, this kind of offsets a good chunk of the work to the database to figure out, do a little bit of, restructuring of the literals to add the question marks needed and so on. But this is the rough gist of things, right? We're not doing that here because I don't have a prepared statement. Now we get to the very last fun one, which is we do have one DSL that works. We are running in the browser, which means we have access to JavaScript. So for instance, we could do some fun things like JavaScript and print out some stuff. But how do we know we're really in JavaScript? Well, the easiest way is to do something that only JavaScript could ever do. So let's alert. And we're going to alert the result of, let's say, 1, 2, 3, and 10,000. And what happens if we just sort these? And so if we run this, we expect a semicolon. We get an alert message, and we can see it's a little small, but we have successfully sorted all of our numbers by alphabetical order. I guess alphanumerical order or lexicographical order. Because, of course, being JavaScript, right, it takes all of the inputs to sort, it converts them to strings, and then it sorts the result based on, the strings, which is, absolutely great because if we were to add something like -7, then you can see JavaScript is smart enough to sort -7 at the front of the list, right? Perfectly accurate every time. So definitely we're in JavaScript land. But even more interesting, this is, the Rhovas editor is running in the browser, right? You can call Rhovas code as a result from that. Well, we can call JavaScript code from Rhovas. So we can use JavaScript tag templates to just make things where we can run Rhovas code. And because, of course, we're in Rhovas, we could use JavaScript, DSLs, to be able to do even more things. So we could have, inception down here. And so let's see. So there's our sort, and there's our inception. So we are now 4 layers deep through languages running things, not to mention the JavaScript VM. If y'all have any other questions, then feel free. But that is pretty much the extent of the presentation. So yeah, one last question.
What would you say are some of the disadvantages of allowing DSL in a particular language for large organizations?
Like, what are the disadvantages of DSLs? I mean, they're all over the place. Like, it's very easy to come up with new DSLs for things that, you know, add complexity. If you're not familiar with the language itself, you could definitely, like, it's less clear than a library in general. The case where you want to use DSLs are generally for like existing languages or very specific problems where you are smart enough to know when is the right case to use that or not. But it's definitely not the first tool you reach for, right? So like, for example, SQL would probably be a pretty standard DSL to be working with, right? If someone comes across SQL code, they shouldn't really be breaking down into tiers at that point, right? It should be reasonably understood how that works. But if you're just going through like a normal Java application and you come across like a function that's half written in Python, that's when it gets confusing, right? But maybe that's a JavaScript application where that's like the one part of the back end where it does, you know, a bunch of data science work. And so it makes sense to call out to a bunch of Python code you have that does like the right thing with NumPy or whatever other systems you have. And so maybe you have a whole other system that's written in Python, and the easiest way is just say, hey, from this language, call the Python code in the other language, because languages are used for different things. And so this is a very easy way to sometimes like build those hooks together to do the best thing in the best situation like that. But yeah, definitely not the first tool to reach for. Yeah.
With API enforcement being a big part of this, do you think Rhovas would be a good choice for microservice heavy apps?
Would it be a good choice for microservices? I don't think anything is a good choice for microservices. I'm not much of a fan of microservices. I won't go into that much, but the short thing is that the more you, like problems have inherent complexity, right? Splitting it up can be a good way if you're comfortable with module boundaries and know the right way to manage all the networking stuff. But in general, like taking a complex problem, dividing it up, and then adding networking into the mix doesn't seem like a great option, right? The general selling point is that it makes it easier for organizations to manage any individual piece for that, which is much more important when you have different teams working on things. It also helps give a compelling reason to make sure that you have like very strong API borders, because if you have a monorepo, it's easier to change one thing that cascades to all the others. If you have microservices, then you can say, hey, if you break the API of this microservice, that's your problem, right? You know, if you need to change that for something, you've got to add like a new version or something else so we can work with these effectively. So I think a lot of the times, like the benefits are not from the microservice per se. It's from the splitting up of that code and really from an organizational level enforcing those module boundaries. So I hope that's something I can handle from Rhovas' side by doing like actual modules and managing that as best as I can. And things like, you know, API compatibility checks between modules to enforce things like that. So that I'd say. But ultimately, like any times when you have a lot of different software components communicating between each other, that's a case where things like API design become, you know, effectively critical. So, yeah. Question?
Out of curiosity, why is there no need for a semicolon in line 18 to close off the curly brace, but there is a need in line 20?
Why is there a need? Fun question. I have zero idea. Do we want to try? What happens? I can tell you why. The reason why is because this is going through a REPL system, and so the REPL system is interpreting this as an expression first rather than a statement. If we were to add the semicolon, that would, you know, still work, hopefully. And then if we were to just say like, you know, print hi, this might not even be hooked up to the right print because it's occurring in a different REPL thing. Yeah, we don't see it here. So yeah, it would still need that semicolon. I think this will give us a syntax error when we start running that. I think it's just disappearing because it's not hooked up to the same standard in and out because JavaScript. So yeah, anyways, yeah, that's a fun question. Yeah. Yep.
How would you define an abstract type?
Abstract type is in what?
Something that would define an interface, a concept, an object meets certain requirements, for example.
Oh, like how would I define an interface? Like I would define an interface, pretty much. So
Could
just
you give us an example?
just interface. Yeah, like the keywords there, you'd pretty much write it the same with class and stuff. I don't have anything set up for user-side inheritance at the moment. Right now, it's all hooked through compiler internals for the things that I've built. And that's primarily because inheritance is a giant mess of a topic that is very difficult to address. So it's something I'm going to continue building for, but I haven't fully addressed yet. It's also because inheritance is not, interfaces are important. Inheritance overall is much less valuable compared to many of the other features, particularly for basic operations. So I will get there at some point, but yeah, not at the moment. Yeah, follow up?
And will interfaces be used to be able to define requirements for methods?
Will interfaces be able to define requirements for methods? Yes, right, in the same way as condition post conditions. I think that's still runtime enforced, so it probably wouldn't, it wouldn't, if I had an interface, let's say, this interface vector or whatever, let's say unit vector. If I had, I think what you're saying is that if I had this function, well, I guess it was a nit. Let's just say vector function normalize, right? This kind of gets what you're referring to, I think, where if I had require this dot x does not equal 0, or this dot y does not equal 0, right? And of course, I need my this up here. I think this is what you're getting at. Could I define something like this in interface?
No, not necessarily. If you're defined, for example, on the unit vector that the incoming argument uses, or at least defines, the interface of vector, for example, would you be able to do that? Because in unit vector, you're checking whether or not they're 0. But couldn't you perhaps, I don't know if you have this planned or not, just say whether or not they adhere to a particular interface that defines whether or not members are 0?
Yeah, I think what you're saying is could I define my own fancy types that say, and I think there was the example that I showed earlier with a custom type definition. So there will be options for things like that later on. We'll see. That's all I got for time though. So we'll leave it at that. Pause things up. Thanks y'all for coming out. Appreciate it. So you're on.